So in section 2.2, we're going to be talking about polynomial functions, okay? What are polynomial functions? Anybody? What is a polynomial? More than one. Poly means more than one. Polygon, poly, more than one, gon, side. So polynomial means more than one what? What is nomial? Nomial is a term. Okay, so nomial is term, poly more than one term. So here we're talking about polynomial functions. So when we have polynomial functions, it says graph polynomial functions. A polynomial functions of degree n is a function of the form, and that's the form. Do you understand what that means? Are they giving you there? Yes. Okay. So this is what they're giving you. Okay. I'm going to use my right here. Notice how you have the n and an n. That is a non-negative integer, which means that that's going to be a positive. Okay. So n is positive. N minus 1, n minus 2, n minus 3, it decreases, so n is 2, 1, and what's the exponent of the last one on the x? Do you have an x? No. So what's the exponent of the x then? 0. Okay, so here the n is decreasing, so let's pretend this is x to the 10th power, minus 1, x to the 9th power, minus 2, x to the 8th, 7, 6, 5, 4, 3, 2, 1, 0. Okay, so all of the polynomials need to end up in x to the 0 power. So you're going to have a constant. This is called a constant function. And it says here, where a sub 0, a sub 1, a sub 2, a n minus 1, a n are real numbers with a sub n not equal to 0. Okay, so then the number here is going to be the number like that belongs to the x to the n power, that belongs to the 1 less than that, and then 1 less than that, and so on and so forth. Okay, now maxima and minima. On the maxima and minima, it says are located at turning points. So the maxima and minima are located at turning points. How am I going to find the turning points? How many turning points are we going to have? Did you remember what I said when I told you about how many turning points you're going to have? At one point I mentioned that in the previous sections. Anybody remembers? No? Okay. Every time you have, for example, if it's x to the 2nd power, how many turning points do you have in that graph? What type of graph is that, x to the 2nd power? It's a parabola, right? It's a parabola. The graph is a parabola. So how many turning points are you going to have? 1. So think about the exponent. The exponent is 2. And if it's only 1 turning point, how can I get that? If it's 2 and 1, so it's 2 minus 1. That's right. If it's a cubic function, how many turning points are you going to have? 2. And do you recall having a graph if it's x? Okay, let me use it up. If it's x to the 3rd power, remember that the graph is going to be kind of like this, and then something like that. Well, you have 2 turning points. You have one here and one over here. You could also have, because of the odd function, you could also have a graph that is just, you don't really get to see. Let me just get a thinner one. There you go. So you could also have the graph just going like this, right? Kind of like that. But turning points, you know, you could have 2 pronounced parabolas, one opening down and one opening up. Okay? And so whenever you're finding the turning points, it's going to be 1 less than the number. So if you have x to the 4th power, how many turning points could you have? 3. The maximum number that you could have is 3. And that's the key. Maximum number of turning points would be n, if n is the exponent, minus 1. Okay, that's the maximum number of turning points. Okay, so let me erase this. Now, and they're telling you that here, if you want to highlight that, it says here, a polynomial function of degree n at most has n distinct real zeros and at most 1 turning point. Okay, so n minus 1. N minus 1. So this is important here. So, see, this is separated, and that's why it's a little confused. But turning points, let me put here. A polynomial function of degree n has at most n real zeros. So this is one fact right here. And at most n minus 1 turning point. Okay. And then we go over the example 1. And the example 1, it says graph f of x equals 2x to the 4th power without looking at the graph. If I don't look at the graph, okay, just by looking at the degree and looking at the positive over here, the number, is 4. So how many turning points are you expecting to have the most? 3. Okay, so the most number of turning points would be 3. And we can see that here. See, this is 1, this is 2, and this is 3. That's the maximum number of turning points. Now, how many zeros are we expecting to have on x to the 4th power? The most would be 3, right? Is it 3? How many? The most. I'm not looking at the graph. I'm just going by what they say on that definition. Right here. What I highlighted. Okay, this is what I highlighted. Where is my volume? Do I have? Okay, so where is that? Right here. You see this? Okay, the polynomial function of degree n has at most n distinct real zeros. So if it was x to the 4th power, how many real zeros am I going to have? 4. So whatever the number of the exponent is, I know, I love that. So anyways, so if it's 4, the more you can have is 4. But I don't have 4. I have how many? 2. So the rule is that whatever the maximum is, minus 2 is the next number of possible solutions that you have. So you could have 4 as a maximum, or 2, or minus 2. 2 minus 2. 2 minus 2. 0, right? So I could have a maximum number of 4, if the 4 of them pass through the x-axis, or 2, or 0. How could it be 0? Well, it could be 0 because I could have the graph like that, not touching the x-axis. Okay, I could have 4. How could I have 4? Okay, let me erase it. I could have 4 if it goes like this, passes like this, and then it goes like that, and then it continues. So there's 4. 1, 2, 3, 4. Okay, so you could have, at the most is 4, and after the 4 minus 2 is 2, or you could have 0 number of solutions. Okay, so here in this problem they were asking, describe the end behavior of the polynomial function using the limits, explain your reasoning using the leading term test. Okay, so then I need to cover those things because later on you're going to be asked about that. So here they're asking me specifically to find the end behavior. Do you remember the end behavior?
Yeah, it's going to be limit.
The limit, there you go. And that's what they have here, okay? So they have here the limit of the function at x approaches negative infinity, what is happening to the function? It goes to positive infinity, and that's what you have here. The limit of the function, as you move to the right, what happens? It goes up, so it's positive infinity. And that's all we gotta give for this one here. And it says here, the degree is 4, and the leading coefficient is 2, because the degree is even, and the leading coefficient is positive. We're expecting to have, kind of like the parabola, if it's an even number, both of them going up, or both of them are going down, isn't it? If it's a negative x squared or negative x to the 4th power, then it's going to be opening down. So here it's positive, it's even, so it's going to be going up. Okay?